Hello again. In this video we will explore what will happen to a mass, or you, if we are on a rotation that is moving around the Sun. Explain the forces affecting you, or a mass on that rotation. We will also look again at the relative motion, inertial reference frames theory. Firstly, what will mainstream physics tell us, if we ask, why do I not feel any motion on Earth? We are told, Earth revolves very fast, at the equator you rotate at over 1,000 miles per hour. The Earth's center is also moving around the Sun at 67,000 miles per hour. You don't feel any motion, because both motions are a constant. You, on the ground at the equator, are you at a constant velocity? No. You are on a rigid body rotation. The rotation is moving, that's translation. Rigid body rotation with translation physics applies. Your motion will be the sum of both velocities. So, what would happen? We will look at 7 hours for you, living on a rotation that is moving. In 1 hour increments, 15 degrees of rotation. From 0500 hours in the morning to 1200 hours midday. Tangential velocity is 1000 miles per hour. Translation velocity of the center is 67,000 miles per hour. You can use this vector addition tool to check the numbers. Your velocity will always be the sum of both velocity vectors. This is basic physics. At 0500 hours your resultant velocity will be 67,270 miles per hour. Then 67,010 miles per hour at 0600 hours. And so on for each hour. Your velocity on the journey around the Sun would be constantly changing. At 1200 hours, your velocity is 66,000 miles per hour. The red numbers are the difference from the last velocity to this point. From 0500 hours to 0600 hours, your velocity has decreased by 260 miles per hour. Your acceleration is minus 3.23 centimeters per second squared. To get an idea of the impact of this acceleration, fill a glass of water to the top. Now, move it 3 centimeters across the table, in 1 second. As we move forward each hour, your acceleration rate changes. We now need to add the two acceleration vectors for the 700 hours point. The first is for the centripetal acceleration, for just the rotation. 3.39 centimeters per second squared. The second, in yellow, is the direction on U, due to decelerating on the journey around the Sun, that's 3.23 centimeters per second. Adding the vectors, the total acceleration on U is 6.6 centimeters per second squared at this point, at 0700 hours. This is the vectors, mapped out for 7 hours. A 100 kilograms person would change in their measured weight, by 300 grams, in 5 hours. Now imagine 100,000 kilograms of water constantly accelerating and decelerating. the International Space Station. It orbits Earth at 17,000 miles per hour, completes one orbit in approximately 90 minutes. Its distance is 4,217 miles from the center of rotation. From point 5 to point 6, 15 degrees of rotation, it takes 225 seconds. The resultant velocity of the ISS changes by 4,140 miles per hour in that time. The acceleration of the ISS would be -8.226 meters per second squared. Again, we will add the acceleration vectors at point 7. Just for the rotation, the ISS is accelerating at 8.51 meters per second squared. Now we add the acceleration on the ISS, due to its deceleration, around the Sun. 8.74 meters per second squared. We add the vectors. Resultant acceleration is 17.2 meters per second squared at this point. From point 7 to point 12, the acceleration of the ISS would change dramatically. From 17.2 to 8.5 meters per second, in a very short time. The ISS would be flung into space within seconds. Anyone in it would be obliterated. On top of all the accelerations, we have more. The Sun is traveling at a constant velocity around the universe. The Earth is going ahead and behind the Sun. The Earth itself is constantly accelerating at a changing rate. Let's look at relative motion and inertial reference frames. The Kryptonite physics video, and this sheet, ends inertial reference frames. If A is different to C, and it is, how can A change when it's put in a carriage with wheels on? It cannot. Changing the relative 2-point on this fairground ride cannot change the experience of the riders. The same as saying relative to the center or next to you on Earth cannot change the experience if you were on this rotation that is moving.